Hello guys, this is Prime Concepts. In this video, we want to consider a very important part of vectors, which is direction cosine. This would lead us to three-dimensional analysis of vectors. So this is really very important, though very simple. Now, remember we've established the introductory part of vectors. We've explained what vectors is. We've considered unit vectors, magnitude of a vector, and some other points, resolution of vectors, addition and subtraction of vectors. In this video, we'll quickly establish and explain what direction cosine is for vectors. Now, say we have a three-dimensional vectors like this. So we have this, a vector in 3D. Let's say this is our x coordinate, which has a direction or a unit vector denoted by I. Then we have this, which is our y coordinate, which has a unit vector j. And then we have this, which is our z axis. It has a unit vector k. Now, if we have a vector that is inclined in this way, let's say we have a vector. Remember, this is three dimensions, so it might be difficult for me to show this diagrammatically. So we have a vector that is inclined in this way. Now we can see that this vector will be inclined at different angles to these different directions, right? So we can say the inclination. Let me try to make it better. It doesn't look too big. So I can do like this. Let's say this is my A. So I can consider the inclination to the y-axis as this. Let me call it theta y. Consider the inclination to the z-axis as this. I'll call it theta z. Consider the inclination to the x-axis as this. Then I'll call it theta x. I can call it alpha, beta, and theta, but I would prefer to use this one so that we'll know which is for the x direction. Now, these are angles that this vector A inclines, or that the angle of inclination for the vector A with the different coordinates, the x, y, and z, right? Now, we can find out that the cosine of each of these angles in the different coordinates, the cosine of theta x, starting from that, the cosine is going to be the direction when you resolve this to the x-axis. So it's going to be ax divided by the magnitude of a, right? So same way, you want to find cos of the angle to the y coordinate. So theta y is equal to ay, then to the magnitude of a, and cos theta z is going to be az, then the magnitude of a. Now, each of what we have gotten, cosine of theta x, cosine of theta y, cosine of theta z, they are all referred to as direction cosine. So they want you to find direction cosine in the x direction. Is going to be cos theta x, which is going to be ax over the magnitude of a. Find the direction cosine in the y direction is going to be this, right? They just say find direction of y. The direction is just the angle, but the direction cosine is the cos of the angle. Direction cosine is the cos of this angle. Now, so this is what we actually need to know, that we can still get some beautiful relationships from this, knowing that A is actually going to be AX I plus what? J plus AZK. We already know this, that you want to write a vector, this vector A, in your Cartesian coordinate. This is how you would write it. So that if you make AX the subject formula from this, you would have that AX, let me do for only this, I would have that AX is going to be the magnitude of A cos theta x. That is what you would get. If you do the same for this, you would get that. Then you can introduce it here. We've arrived at what we need. This is what you have. We have as the direction cosine. We want to do an extra relationship because exam can twist question in different ways. So I would have that A would be, instead of AX, I would have magnitude of A cos theta x, then the direction, which is I, plus magnitude of A cos theta y, then J, plus magnitude of A cos theta z, which is what? K. So this is what you would have. So you can easily see again that A, you can factorize this magnitude, which is common. You would not then have that this is going to give you cos theta x I plus cos theta y j plus cos theta z k. So this is what you would have. So again, you can write this as A over magnitude of A. If you divide by this, right, then you would have cos theta xi plus cos theta yj plus cos theta zk. Now, what are you noticing? You're noticing that A, from our previous video, that A over magnitude of A is referred to as what? A unit vector. A over magnitude of A is called unit vector. So what it means is that if this is a unit vector, it means that we can define a unit vector of A in terms of the direction cosines of the x, y, and z direction. So it means we can actually say that a unit vector can also be defined like this, because this is actually A over this, which is known as, which you call unit vector. So A is a unit vector, which if you check our previous video, you'd understand this. Remember, we said a unit vector is a vector whose magnitude is 1. So it means another definition for a unit vector, apart from this, which we have known, is that we can say that a unit vector A is going to be the cosine in the x direction, cosine in the y direction, and then cosine in the z direction. You can say this. So this is another definition for unit vector in terms of the cosine, right? Yeah, so it means that if you want to find the direction cosine, all you need to do is to find unit vector. Once you find unit vector, from there you can identify cos theta x, which is the direction cosine, cos theta y, cos theta z. I'll show an example how to find the direction cosines. All you need to do is to find the unit vector. When you find that, you can obtain the direction cosine for x, y, and z direction. So you take note of this special relationship, and then in addition to this, we already know that for a unit vector, the magnitude of a unit vector is what? 1. Now, if that is the case, it means that the magnitude of this should be 1. Therefore, the magnitude of this is going to be the square root of cos theta x all square, or let me write it in a more mathematical way. So this is going to be cos squared theta x plus cos squared theta y plus cos squared theta z, right? Yes, this is the magnitude, and it's going to be what? 1. So that if you remove this square root, you can easily see a proof that cos squared theta x plus cos squared theta y plus cos squared theta z is equal to 1. So this is a mathematical proof for 3-dimensional vectors. Just like you know for your normal trig, cos squared theta plus sine squared theta is 1. So this is another proof for a vector inclined in 3-dimensional space. That's cos squared theta x, theta y, theta z would be what? 1, and this is true. So if they give you this and this, they want you to find cos theta z, you can always find this. So I'll give one example that can help us digest this concept very quickly. All right, now let's analyze this example very quickly and draw the video to an end. And they said given a vector A equals this, find the direction cosine of this vector. So an easy thing to do, remember the direction cosine is going to be cos theta x, cos theta y, then cos theta z. These are what we want to find, right? An easy way to solve is to recognize that the direction cosine is related to unit vector. And what is a unit vector? A unit vector is given by the formula this, which is equal to A over the magnitude of A. Hence, once we can find this, we can find the direction cosine. So in order for you to find this, the only thing that is missing is the magnitude of A. So let's quickly find the magnitude of A, which is going to be 4 square plus 2 square plus 3 square. So this is going to give me the square root of, so this is 16 plus 4 is 20 plus 9 is 29. So I have 29. So this is the magnitude of A. So I can quickly write this unit vector. I can write it as A. And what is my A? My A is 4i plus 2j plus 3k divided by the magnitude of A, which is what? Root 29. So I can split this by saying that this is going to be 4 divided by root 29, then I, plus 2 divided by root 29, then j, plus 3 divided by root 29, then k. So if I've been able to do this, it means that my direction cosine in the x direction is this. So it means I have cos theta x would be the coefficient of I, which is what? 4 by root 29. A direction cosine for y, cos theta y, is going to be 2 by root 29. A direction cosine for z, cos theta z, is going to be 3 root 29. So these are the direction cosine respectively, so that you would see that if you take the square of this plus the square of this plus the square of this, add them up, it will give you 1. So we have been able to show that. So with these few points, I believe that the concept is really clear to you. If you didn't watch my videos from the start, do well to go to my channel, click the playlist for vectors, and you would see the vector analysis from the introductory part, which would really help you to understand this. If you have watched this video up to this point and you are yet to subscribe, do well to hit the subscribe button, turn on the notification bell, like this video, comment, and share to 10 of your friends. Tell them it is Prime Concept. Thank you. I'll see you in my next video.